Welcome everyone. My name is Ixta Gerard, Director of Marketing here at Appgate. I want to thank you for joining our live SDP democast today. So three things that we're going to cover in this democast. One, how Appgate SDP works as applied to federal government or DoD. Two, the core components of our unique direct routed architecture. And three, a behind the scenes technical look at the SDP admin console and client. Throughout the democast, we will highlight the significance of Appgate SDP in meeting the rigorous security demands of the federal government and DoD, ensuring that sensitive information remains protected and critical operations stay resilient against evolving threats. Also, a few housekeeping items. This webinar is being recorded and you will receive the recording in 24 hours. This is a live session, so you can submit your questions through the Q&A panel, and we will be happy to answer them during this session. If for some reason we don't have time to cover them all, we will follow up with you via email. There is a short survey at the end of this webinar, so if you could please provide us with your feedback, we'd greatly appreciate it as it helps us improve our future webinars. We are very grateful to have you with us here today, and we're looking forward to a great informative session with our software-defined perimeter expert presenting today, Jonathan Roy, Principal Architect for Appgate Federal. Enjoy the session, and now I'll turn it over to Jonathan.
Thank you. I appreciate it. I'm going to share my screen now. Are you able to see my screen? Is it sharing?
Yes, I can see it.
And just as a forewarning, I'm not going to be full screening my presentation. I'm going to be popping in and out of slides to keep this more interactive. I'll be jumping into my live environment fairly frequently. So again, my name is John. I'm one of the architects here within the Appgate Federal team, and I'm really going to walk you through, the Appgate capability set, kind of the differentiators, and how we apply this technology to the federal government and our DoD partners. So I'm going to get started here. So this slide here is really kind of capturing the overall essence of software-defined perimeter. The way I like to think about it, it's making sure the right user gets the appropriate level of access to the right resources at the right time. So starting from left to right, you look and see identity. So it really starts off with Appgate wants to learn as much about the user as possible. So think of us tying into one or many identity providers to really get that enhanced, enriched data. We want to know things like the roles, the groups, the attributes about those users as they're signing in. We want to continually monitor those elements as well. The second piece is we take identity and we combine it with device data. So think device compliance, device health. In DoD terms, it would be things like STIG compliance, understanding if something is a bring your own device or government furnished or GFE device. So making that understanding part of our solution here, really understanding, again, the identity plus the device. And thirdly, the way I kind of wrap it all up is kind of those external environmentals. It could be things like what's your geographic location, time of day, risk score associated with that user or the device. Did they provide a multi-factor, CAT card, PIV card, et cetera? But think of it as using all of those elements in composite to make a real-time access decision and continuously monitor those elements and either restricting, granting, or revoking access based on what Appgate's learning in real time. I'm going to skip to the right side. The right side has a really good, very high-level graphical depiction of how we deploy the Appgate software-defined perimeter. You'll notice that there's a number of different elements. We have these rectangles representing data centers. We have some cloud environments. And what we do is we apply our platform as gateways in front of these points in your infrastructure. If you're familiar with the NIST 800-207 framework for Zero Trust, they break it into three core components. It's a policy decision point, a policy enforcement point, and a policy engine. There are some other elements behind the scenes, but those are the core pieces. And if you're applying that framework to Appgate, just think of these gateways as the policy enforcement points. And I'll get into the other elements of the architecture here shortly. But there's kind of two key pieces that you're going to notice initially looking at this graphic. You're first going to see the user who's directly connecting to resources. One of the key pieces that I'm going to really dive a little bit deeper into is the difference between Appgate being direct routed versus cloud routed. So you'll notice when the user's connecting to infrastructure, it's a direct path over the most performant path to get you to that infrastructure. It doesn't have a proxy that you connect to first, and I'll explain that here in a minute. Within our architecture, you'll notice that this user is now having direct access to multiple points in your enterprise. And if you think about how enterprises are normally architected, there's usually one ingress path in if you're remote, as an example. So if you have like a virtual private network or VPN, you turn on your VPN and you connect to that large concentrator somewhere in your enterprise, and then you rely on kind of back-end routing to get you to the appropriate things. But in this model, it's a one-to-many connection, not a one-to-one. So that's it has its advantages, right? You having, access to resources directly. But if you think about it from an adversary's perspective, it's not just one pathway in now, it's potentially multiple paths into your environment. So how do we protect against, this very distributed and elastic architecture without enhancing or increasing the attack surface? And that kind of brings me back to the second piece. This is, our capability that we have to keep that entire enterprise edge cloaked or undiscoverable. So what that means is even though our resources that we're protecting and our platform can be geographically dispersed and you can reach it from anywhere, we want to make sure that an adversary is unable to reach them if they're not part of your ecosystem. The technology under the covers that we employ to do that is called single packet authorization. Think of it as a specially signed token that we have to provide to our platform in order for it to become visible to you. This is kind of where I like to start my very first demo, so you kind of get an understanding of what I'm talking about here. What I'm going to do is I'm just going to do a scan using my machine here against Appgate versus other between, what do you mean by cloaking? So the cloaking piece is pretty straightforward to understand here. I'm going to go ahead and bring up my command prompt. So from here, I'm going to be able to do some basic reconnaissance scans on pieces of infrastructure that we can discover. So as an example, I'm doing a scan. That's what Nmap is. Think of it as doing a mapping of the network. And I want to see if there's any points of presence available. So the IP address that I pulled off here was from a different vendor solution. So it could be another zero trust access solution. It could be a VPN solution. And I'm going to see if it has open ports that are listening and willing to accept connections. So if I do this scan, you're going to take a note that is going to return that, yes, there's a bunch of ports open. There's port 443 open, port 80's open, port 21's open. And this is kind of by default how these technologies have to work. They have to be waiting and listening and open for you to connect to them. So imagine your legacy VPN. They're going to have this open socket for you to connect to enterprise resources. Now, Appgate fundamentally is going to need to do the same thing. We're going to have our platform sitting on the edge of your enterprise, but it needs to be reachable from everywhere. To get to kind of understand how my Appgate environment is configured, I like to show the agent that we have. So we have an agent that we can deploy on end user devices. And my agent is configured to go talk to my Appgate environment that lives in the cloud. So just imagine I'm connecting to this platform here. Now, the main difference is if you look at how this agent's configured, I'm pointing to the name of my environment. It's called my controllers at stpfederal.com. And I'm going to do that same scan against my environment. And we use the same ports. So if you look, I'm doing a scan against STP controllers at stpfederal.com. Appgate uses the same ports like 443. And you're going to take a note that it's going to look like my environment doesn't exist and the host seems to be down. So from a reconnaissance perspective, you can imagine you're not going to get that initial response. You're not going to be able to figure out, well, what software version that appliance is running, what firmware version, are there any CVEs or exploits available that can be launched? Because we know that this one will respond where Appgate won't respond unless again, I've sent that very specially signed packet during my sign-in process. So that's probably the easiest way to demonstrate what single packet authorization is. Again, it's keeping our platform undiscoverable unless you're onboarded into our platform, which means you have our software installed on your machine and you're participating in the Appgate environment. There's two other core differences besides keeping the enterprise edge cloaked. The second one I'd like to really harp on is this concept of direct routed versus cloud routed. Direct routed means our platform can live within your existing security boundary. I'm talking the control plane, the data plane, the management plane. There's no need for user traffic to go to an Appgate cloud before it then goes to your infrastructure. So when you're looking at, zero trust access, really understand like where your data is going. There's a lot of advantages to a direct approach. We can have full control over how that user's traffic is routed from the user device to your environment. From a logging perspective, there's very robust logs that we're going to be able to obtain because again, you control the infrastructure, the virtual machines that are running the Appgate capability stack here. And then one of the nice pieces is, even though a lot of these graphics don't inherently depict this, most folks think zero trust access is all about remote users coming into their resources or the enterprise resources. If you want to kind of just flip that on its head a little bit, well, what about your on-premise users? If you have physical locations, so we're working with a number of different departments within the federal government, and they have a large user population that lives on these bases, camps, posts, and stations, and they want to have, security controls applied to what those users can get to. Can you imagine that solution requiring them to literally route outside of the base, go to a cloud, and then route right back? So just fundamentally, you're creating this huge hairpin when you have these cloud routed solutions. And secondly, you've kind of lost positive control of your data because it's now egressing your security boundary, being routed through a multi-tenant, managed service provider's cloud offering, and then proxied back to you. And that's really the main difference between Appgate being a direct routed solution versus, I'd say, almost all of our competitors are our cloud routed approach. And graphically, just showing here, the user, in order to get to the resources, has to go through this brokered cloud solution. One of the other main advantages with this approach that we really like to harp on when we're talking to our federal government customers is, think about disconnected operations. You could have 4 deployed elements that may be operating, in environments where there's not a lot of great communications. Connecting to the cloud is not really reasonable or even possible in some of these environments. Or even think, use cases like the Navy. They have, shipboard operations, and as soon as they go over the horizon with these vessels, getting internet connectivity to the cloud is sometimes just not possible. So how do you apply zero trust when you have this cloud dependency? And that's one of the other pieces Appgate really differentiates itself in the federal market specifically. So again, directly routed versus cloud routed. So those are the first two that we've covered that really makes Appgate different. So we talked about keeping the enterprise edge cloaked. We talked about direct routed versus cloud routed. And the third element that I really like to harp on is this concept of a data-centric policy engine. When I was first speaking, I talked about, yes, we learn about the identity of the user, we learn about their device, we learn about other environmentals like geographic location and their risk score. Those are all great, and we use that to decide what you have access to, but defining what you have access to is actually one of the hardest parts when you're trying to develop zero trust. When you look at organizations today, I go into some of these environments, there's, honestly, tens of thousands or even hundreds of thousands of, firewall rules that are talking about, this user or this set of users with these IP addresses need to access these resources. And here's, the hundreds or thousands of IP addresses that they need to have access to. When you start multiplying that by, tens of thousands or hundreds of thousands of users, you get this highly complex, very stale and, static environment, because you're literally mapping one-to-one about what a user has, their IP to what they can have access to. Zero trust from an Appgate lens is really about being much more dynamic and much more adaptive. And the only way to really do that is to really decouple completely from the underlying compute infrastructure and the network as well. So the way we achieve that is, again, what I'm calling the data-centric policy engine here. So if you can imagine, I have a number of workloads I'm graphically depicting here on the right-hand side of, applications. And to keep it simple, I'm using colors to depict these applications. It could be, the blue application stack, could have the red application stack here, or even like the green application stack. And the idea is, under the covers, these could be comprised of, tens or hundreds of IP addresses, especially when you're talking about containerized environments where they're very ephemeral in nature. They're booting up, they're turning on, they're consuming an IP address, they get spun down, and then, new containers spin up. They may have different IP addresses, or something as simple as maybe you have a application server and it simply reboots. And if you are familiar with AWS, when you reboot a system, it very frequently gets a new IP address. So how do you have, this environment where you're trying to create security controls and you're relying on IP addresses to manage it, and then you're at the same breath, you want to have this very adaptive, way to enforce who has access to what. And that's kind of where our concept of using tags and labels to drive access versus IP addresses can really reduce your overall complexity pretty significantly. In this model here, I'm just showing some examples of different platforms that we can use to resolve these tags and labels. One of our key partners is Illumio, as an example. They do a very good job of understanding the different applications in an environment. They'll label an environment as, here's the red application, it's located in AWS East Coast region, and it's a IL5 application. So when I'm writing an Appgate rule, I'm simply saying, I'm Jonathan, I have the red attribute. That means I can talk to anything that's tagged or labeled red in IL5 in production. So it's a very human readable way to write security policy. And the cool thing about that is if the underlying network IP schema changes, right? So if these containers grow and shrink, if a workload moves from on-premise to cloud, the tag and label follows that resource around. So it really makes it very dynamic in how we can achieve matching a user's access to what they have access to. So again, there's a number of different platforms that we can consume the tags and labels from, whether it's, getting tag data from a data catalog like Calibra, or one of our other partners, Immuta. We can get it from an identity provider or a federation service like Radiant Logic. So that's really the three key differences. So to kind of sum that up, keeping the edge cloaked, direct routed model, and using tags and labels to define access. I didn't mention this earlier, but tags and labels in the DoD space is, pretty significant when you think about creating compartmentalized environments and enclaves, where you have different enclaves to support different missions, and you have coalition partners and mission partners and external parties. Again, managing that with IPs is, pretty untenable. So that's really the kind of the key differences there. And let me jump into, how the platform works. And then I'm going to show you under the covers, going through the Appgate management interface, so you can see, kind of end to end how we actually end up building policy. So when I was speaking earlier, I talked about the Appgate platform is really in direct alignment with that NIST 800-207 framework for zero trust. So that means, a policy decision point. That's the first one. So our controller is that policy decision point. It actually has a co-function of being that policy engine, because this is where you're going to write policy that dictate these types of users have access to these types of resources under these criteria or conditions. The second piece is the policy enforcement point, or the gateways. And that's really going to make that decision on, yes, you've qualified to access a resource, but do you meet the conditions to have access or continue to access that resource? So this kind of, think of those two elements of, in some terminology, some folks, instead of policy enforcement and policy decision, they like the idea of control plane versus data plane. So that's, another way to think about it. In our demonstration environment today, I'm primarily going to be navigating to the administrative interface of our controller to kind of show you how we build these policies, and then show you how a user would sign in using their identity and device data to get aligned with a policy and then be granted access to resources. Now, the interesting part about this slide, this is an animated slide. I don't like to go through the animation because I just want to really kind of get the concept across. You'll notice that there's an I with a slash through it on the controller and gateways. So just kind of go back to the original demo that I showed, where we're scanning the Appgate platform looking for a response. And that's why we're showing that these are not visible, because the platform itself is, undiscoverable. So the way we're actually able to still connect to our platform is, again, that concept of single packet authorization. And what does that mean? So the simplest way to think about it is, when I install the Appgate software from this instance of Appgate, think about a very specially signed key or a certificate, and there's an easy way to think about it, is really generated for you and your device and installed on your device. And we actually use those tuples, those components, to create these single packet authorization tokens. I'm going to start calling this SPA for short. We call it a SPA token. So the only way that our platform is going to respond to you if you send that very specially signed SPA token first. So imagine I'm attempting to connect to the controller. If I don't have Appgate and I don't have that SPA token, I never get a response. But since I'm going to be onboarded into this platform and I have the software installed and it's registered, I am going to get a response when I sign in. So in this example, the user, they attempt to connect to our controller infrastructure. And just for clarity's sake, I'm only showing one controller in this graphic. In most environments, there's multiple controllers that are geographically distributed to support a large geographic footprint of a user base. But this, again, just is a very simple graphic. So the user, connects to the controller. The controller is going to do that assessment of user identity, pulling out attributes, going to do that device posture assessment. It's going to understand things like geographic location. It may go talk to other systems in your ecosystem. So let's say you had a Splunk or a McAfee or a Carbon Black, or really any other security tool. Appgate is going to want to get as much telemetry from any solution to add some context to, is this a valid user or not? So just think of the controller as really not only wanting to start authorizing identities and devices, but validate those things against other tools in the environment. So once it's done that initial process, it wants to create access policies for you. So as an example here, this user has access to a set of applications that are behind this Appgate gateway. The flow from there is pretty simple. The controller, aligned you with the policy. The policy that we'll actually build in our live environment today will be something like the red application. So we'll say, as long as you have the red group or the red attribute, you'll have access to anything that's either tagged red, has an IP address for red, or has an FQDN for red, because you can define it in a lot of different ways. So think about that entitlement also being a token, right? That token is going to now be able to be sent to the end user's device. The Appgate software is going to interrogate that token, check the validity of that token, and it's going to use that token to say, well, I'm being, configured to go connect to a gateway, the policy enforcement point. So all that information about which gateways the user is going to connect to is all inside of that entitlement token. The entitlement token goes to our gateway. Our gateway looks at the entitlement token. It validates, is this the right user? Is this the right device? Is this a properly created entitlement token? It does all those checks you would expect. And then from there, it's going to make a conditional access decision. So if you've put conditions on that entitlement, like you must be stick compliant, and we may check that every 5 minutes, or you must provide a multi-factor, or your risk score has to be below a 75, or you have to be coming in from the continental United States or CONUS region. All those conditional access checks are performed and executed on the gateway. So that's really the simplest kind of high-level view of an Appgate architecture. To kind of give a little bit more depth to that, this graphic here kind of shows a common way to implement Appgate, where you have multiple gateways that are deployed across multiple sites in the environment. But what I want to do now is I want to jump into a demonstration and really have this go end to end for you, given that we only have a few minutes left. So here's a demonstration environment that we have built. These gears represent controllers. Again, that's where we create policy. These blue circles represent gateways. And remember, the user can have connections to multiple gateways or multiple sites directly, right? That one-to-many connection versus a one-to-one that you may see with other solutions. The controller here is going to be tied to one or many identity providers. So what I'm going to do now is I'm going to jump into one of my controllers, and I'm going to show you how it's configured. We're going to create a quick policy on granting myself access to a resource, but I don't want to be granting access based off of an IP address. I want to base it off of how something is tagged or labeled. And as that tag and label changes, I want you to show everybody here how real time my access changes based off of something like a tag or a label here. So with that, I'm going to jump into my Appgate environment, refresh my screen here. All right, so this is my controller. Again, this is in AWS right now. It has a summary of all the elements in my environment. And to really kind of have this go end to end for us during the demo, I'm going to go ahead and sign in as a user. And just keep in the back of your mind, there's really two primary ways we deploy Appgate. We have an agent that we can deploy where I can sign in, and it's going to either prompt for a CAT card. In this example, I'm using a SAML provider to sign in, and this is the scenario where I could then, be prompted for a CAT card or some other type of strong authentication. And let me unlock my 1Password here. And I'm going to sign in. For the demo today, I'm going to sign in as a user. Her name's going to be Robin. So I'm now signing into my SAML provider here. And in the background, what's happening, Appgate, looked at my device, it looked at my identity, and it decided which entitlements I have access to. And you'll be able to see here that I'm now dynamically connected to 4 sites at the same time. Again, it's that direct routed methodology. But I really want to get into understanding what Appgate learned about what I just did when I signed in. I'm going to come down in here to home, and I'm going to hit active sessions. And I have my user that I just signed in with right here. Here's Robin. So if you take a look, here's Robin signed in from a MacBook. Here's my operating system type. And there's a number of different tabs at the bottom that are pretty important. The first one is things like, system variables. So think of things like geographic location, what state, what's my Latin long. Another tab here is identity data. So this is things that we can be pulling from one or many identity providers. So if I cared about, what groups I belong to, so I'm part of the red group, I have, what's my duty station? It could be Hanscom Air Force Base. Did I complete my IA training? How many devices do I have issued? What's my current risk score? All of those things we're going to be able to use in policy to say what I have access to. So a very simple policy that we're going to create today is really going to be based on these elements. We're going to say, if you're part of the red group, I want to grant you access to an application called Databricks, and that's a demo application I have in my environment. We also can get device data. So if you want to know if a device is STIG compliant, what's the complexity? Is the password complexity settings, if you cared about what's the timeout for the screensaver before it locks, is there a DoD or federal civilian issued machine certificate associated with that device? So there's a lot of things that we can query about the device to include, is a certain other piece of software running and up to date. A common integration is with a platform like McAfee, where we want to not only check is the process running, but has it been updated with the right signatures in the last 4 or 5 days. So all of those things we can learn and store as variables in our environment and really make policy based off those things we're learning, and it's completely customizable. So the quickest way to kind of wrap this demo up, I'm going to go ahead and create a entitlement, and I'm going to create a policy that's going to grant Robin access to that entitlement. And so you can kind of really see that end-to-end flow. So in order to create an entitlement, it's pretty straightforward. I'm going to come over into access, and I'm going to create an entitlement here. I actually already have a entitlement, I believe, for my environment, but we'll go ahead and create a new one. I'm going to create a new entitlement, and the name of the application is going to be Databricks is the name of the application I want to grant access to. And this is going to be in my AWS environment. And I have to define, well, where is this resource? And normally speaking, folks are very familiar with using IP addresses. One of the powerful pieces to Appgate, again, is that concept of tags and labels. So if you look at my AWS environment, I have the resource in here. The name of the workload we're going to be getting to that has Databricks on it is here. If I take a look at this system, you can see here's the IP address of 10.10.1.4. But instead of using the IP addresses, we can use the construct of tags that's already available in some platforms. So in this example, I'm going to end up using a tag from AWS to define my access. So right now I have a tag, key value pair of app and Databricks. Right now it says dev Databricks, but I want to only grant users access to things that are, quote, in production and tag Databricks. So when I'm defining what Databricks is, instead of using, I could, do this by name. So if I had databricks.lab.io is the FQDN for the resource, but where tags can come in is that we can just simply do direct API calls to the underlying platform. So an example here would be the tag equals Databricks. So under the covers, this could be 10 or 100 IP addresses. And as that workload changes and maybe picks up new IPs, Appgate's going to be continually monitoring those labels and those tags and dynamically change my access in Appgate. So again, we can definitely do IPs, FQDNs, but we really try to push our customers towards this concept of tagging and labeling. From there, you can select, what ports you want to grant access to. I could grant web access, UDP access. I can control, and filter within an HTTP string. For this demo, I'm just going to do a quick ping. I'm going to ping this resource. If if the tag is appropriate and I have the right attribute, I should be able to get a response with ping. Now that's one half, right? So we've defined the what I have access to. But now you have to define, well, what are the conditions that need to be met in order to grant myself access to this resource? You may care about, well, you need to be STIG compliant is the first one. Maybe I also want to make sure that you completed your, IA training. The other one could be really anything that you want, right? So we could say, your risk score has to be below a 75. You have to have completed your training, and you have to have a STIG compliant device in order to be granted access to how we've defined Databricks. So I'm going to go ahead and remove the IP addresses here. We're just going to use the tag to define the resource. So now we're going to come over into policy, and we're going to create a policy for Databricks about who can have access to that resource. So we're going to do a Databricks policy. That's great. And now we have to come down, and we're really having to tie the what to the who. This is where those both get combined. So the what is what we just got done creating, which is Databricks. Here it is. So you're saying, here's the what. You're going to say who has access to it now. And this is where you define the who. So you first start off with typically an identity provider. Again, we can support multiple identity providers if you want to do CAC authentication, Ping, Okta, Azure AD. For this demo, I'm using Radiant Logic SAML as my identity provider. That's the first criteria. I have to sign in with that identity provider. The second could be something as simple as groups. If you remember, when I was showing you my session, Robin was part of the red group, right? And then you can get as creative as you like after that. You can see there's a number of criteria that we can use to define who gets access to it. If I cared about certain country codes, state codes, Latin longs, if I cared about, certain duty stations, if you're part of, stationed at Hanscom Air Force Base, as an example. Now, anybody who's qualifying for, they signed in with Radiant, they're part of the red group, and their current duty station is Hanscom Air Force Base, they're going to get access to the Databricks app as long as they meet the conditions. To kind of show you all this happening in action now, I'm going to go ahead and attempt to ping this resource that we just created this rule for. So if I copy this IP address here, I'm going to bring up my command prompt and go ahead and ping this guy. And right now the ping should fail, because if you remember, we actually have this tagged as dev Databricks, not Databricks. So if we imagine there's a workflow that got executed where we're moving an application stack from development to production to start granting users access, that could result in a workflow that creates or modifies an existing tag. So I'm going to change this tag from dev Databricks to Databricks and hit save. And of course, there's typically going to be a workflow of approvals involved with that. But ideally, you can see here, the moment that tag changed, my access changed. Now just extrapolate that out to my device posture changed. Did I provide a multi-factor? Did my attribute change in the identity store? Really, any of the elements that we're monitoring are really going to dynamically change your access in the environment. So if we wanted to roll this back, it's still pretty straightforward. Let's say for some reason that application gets moved back into development. I'm going to come back down in here. I'm going to move this back into dev with some type of workflow, typically like a Argo CD or some type of CI/CD pipeline integration is going to be happening. But as a simple demo, I'm manually just going to change this tag. I hit save. It's no longer in development. It got moved to production. And within like 1 or 2 pings here, I'm losing access to the resource. So that's really a really great way to understand the Appgate platform in a live environment. Lastly, I'll end it with this. We've aligned Appgate with all the federal zero trust models that you would expect, whether it's CISA, the DISA zero trust architecture. We're also working with NIST and all the great work that NCCOE group is doing, where we're a contributing member there. But this is just a very high level graphic showing how we've mapped Appgate to those pillars. CISA having the 5 pillars, DISA having the 7 pillars. And we've made a really quick sheet. Now, under the covers of this, we have a pretty elaborate matrix and test plans and procedures if you wanted to actually implement Appgate to meet some of those controls. So a lot of organizations today are doing their gap analysis where they're trying to say, hey, I have a problem with microsegmentation and let's say, conditional access. So you'd go to our matrix, see if we meet those. And if you're curious on how, you pull up our test plan and procedures, you can see how you can build a demonstration environment or a lab environment or a pilot environment and actually test Appgate against that use case specifically. And it also includes the steps from the administrator's perspective, what you'd have to configure to meet that control. And it also includes how the user testing would be accomplished. The user's going to do the following steps. So it really makes it easy for an organization to say, I want to mature on my path to zero trust. Here's my gap analysis of out of the 150 controls, I'm missing these 40. And you can very easily map that to Appgate and really understand quickly how to execute and implement them.